Let's tidy up all those things we learned from the decimals. First of all, make sure your name's on the top of it, okay? Okay. No, it's 2 day. Okay, so here's what quadratics and roots are. These are solutions to quadratic formulas. Okay. The quadratic roots are always going to be where they cross the x-axis. So what were some of the words we established for these roots? They're called roots. What else did we call them?
Solutions.
Okay, solutions. What else? Zeros. We call them roots, solutions, zeros. What else? Well, we have roots.
Parabola.
We also can call them
Answer.
x-intercepts, solutions, zeros, roots. Okay? And things with two solutions cross twice. Things with one solution just touch the x-axis.
I did it.
And no solutions will never, ever, ever touch.
What's the date? It's today.
So let's put this to work. I know there's going to be a parabola on here somewhere, and I want it to cross the x-axis. So to see that, how am I going to graph this parabola? What am I going to do first?
Put the x-intercept. Find the axis of symmetry.
The axis is symmetry, right? So the axis of symmetry is -4/2, or -2. So I'm going to put that right in the middle of my table, right? This is a review of last night. If x is -2, I'm going to substitute that in to get my y value, to get my vertex. (b/2a). So I got a 4, -8, -9. Everybody go with my vertex? Okay, then I'm going to stack 3 less and 3 more. Now, as you're doing these, do I need to substitute all of these in? No, just half of them. Right? I'm going to do the bottom half. Actually, Nate made me almost do the top half just to be a rebel, but I'm going to do the bottom half, okay? So let's put in -1. Guys, roll with me. -1 squared. 1 minus 4. -3 minus 5. Which means these are both -8. That's the way the axis of symmetry works, right? Let's slap a 0 in there. What do we get? Yeah, that's the easiest one, right? Both terms go away because that times 0 is 0. And then let's slap a 1 in there. 1 squared. 1. Plus 4. 5. Minus 5. 0. So I'm going to graph all these beautiful, beautiful points. I'm going to do it in red. It's looking dark up there. 2, 3, 4. -5, 0. I got a 1, 0. -4, -1, 2, 3, 4. -4, -5. I've got a 0, -5. Got a -1. I got a -3, -8. I got the -2, -9. Isn't it kind of cool that social studies and math both like Soldier Boy? Anyway, there's my parabola. Now, speaking of these zeros, these roots, what are the roots of that function then? Yeah, I like writing it like this, but yes, -5 and 1 are the solutions to this quadratic function. It's where it crosses the x-axis, the zeros. All right? Cool. You good, man? So taking a look at number 5, we can do a similar thing here, where we do (b/2a) to get our axis of symmetry. What is (b)? 0. So, yeah, my axis of symmetry is 0. That means my vertex is going to be on the y-intercept. When I plug 0 in for x, what does it pump out? 9. That's that spot right there. I'm going to stack negative 1, negative 2, negative 3. 1, 2, 3. Which one's easier to do? It's kind of the same. Because here's the deal. When you square any of them, they all end up being the same, right? It's kind of cool, right? But don't forget, this means the opposite of x squared. So when we slap a 1 up in there, we do 1 squared first. What's 1 squared?
1.
The opposite of that, though, is negative 1 plus 9, 8. So these are both 8. We slap a 2 up in there. What's 2 squared?
4.
Opposite of 4. Plus 9? 5. Let's slap a 3 up in there. 3 squared?
9.
Opposite of 9?
0.
Plus 9?
0.
Good. Thank goodness, because it wasn't looking like we're getting zeros for a hot second. So 0, 9. I got negative 1, 8. And then you can kind of, do you even see how you can just like make your dots mirroring? It's kind of fun. 2, 3, 4, 5. 5. And then negative 3, 0. And 3, 0. Man, it's so much fun. I love drawing this. There's our parabola. And then, so what are the zeros here? 3 and negative 3. Now, I'm about to show you something kind of crazy. You can do this one, which we'll have a whole lesson on later. But just like follow me on this. Don't write this stuff down. But it's going to help us do the next thing I got to teach you, kind of. So don't write this down, but you need to follow me. So what do you know is going to be true no matter where it crosses on the x-axis? Y is going to be 0. Just like when we did x and y intersects the lines, right? No matter where we're at on this x-axis right here, y is going to be 0. So check out what I can do here. Now here's why we couldn't do that before. If you have something like this and I put 0 in for here, can you solve for x? Not as it is, right? Not as it is. And that's because there's two terms with x. This one has a missing b value, right? So I can solve for x. Let's do it. How do I get rid of plus 9? Minus 9. So negative 9 is negative x squared. How do I get rid of that negative 1? Divide by negative 1. So x squared is 9. How do I get rid of that square? Now, here's where things get interesting. What can x equal?
Negative 3 or 3.
Yeah, it's 3 and it's negative 3, right? Because 3 squared is 9, and negative 3 is also 9. Did you guys check our answers? So these things that have 2 solutions, here's what's happening. There's a square root of a positive number happening. Okay? You guys see that? Yeah, Mas? Man, that's a weird question asked right there, but sure, man. So here's what I'm going to show you with these 2 answers. Go to the bottom of your notes. Do you see where it says the discriminant?
Yes.
Okay? The discriminant has a formula. And that formula is the discriminant is equal to b squared minus 4ac. All right? That is the discriminant formula. Let me show you where this comes from. Don't write this part down. I'm writing this little box over here. Don't write this down. It comes from the quadratic formula. The quadratic formula, you can plug any quadratic function into, and it tells you the zeros or the roots. Okay? And it is negative b plus or minus the square root of b squared minus 4ac over 2a. This is the quadratic formula.
Is that 4 AC?
Yeah.
I'm broken.
But no, you just need to say like, okay, I believe you, Mr. McKenzie. That is the formula.
I believe.
Okay, now see this thing called the discriminant, which is b squared minus 4ac. Where do you see that in the formula? Under the square root. Under the square root. So follow me here. If I were to take the square root of a positive number, how many answers do I get?
2.
Yes. If I take the square root of 0, how many answers do I get?
1.
And if I take the square root of a negative, how many answers do I get?
0. Oh, so it's like
So the discriminant portion of that will tell you how many solutions there are. And it's kind of nice sometimes to know before you do extra work just to get no answer. And it all deals with that square root. That's why they're called roots. Okay? So if we just do b squared minus 4ac of any quadratic function, we know how many solutions there are to that function. All right, so let's put it to work. Number 7 on your notes. y equals x squared plus 5x plus 4. If I put in b squared minus 4ac, so 5 squared minus 4 times 1 times 4. Okay. Standard form is ax squared plus bx plus c. That's from 2 days ago. So the discriminant, this would be this for x squared plus 5x plus 4. B squared minus 4 times a times c.
Is that 5 squared minus 6?
That is 5 squared minus 16. Or 25 minus 16, which equals 9. So a positive number has how many solutions? Because if I were to take the square root of that positive number, there's 2 answers. Let's look at number 9 on your notes. Y equals x squared plus 10x plus 25. Okay, I'm gonna do the discriminant, which is b squared minus 4ac, which would be 10 squared minus 4 times 1 times 25. That gives me 100 minus 100, which is
0, which is 1.
and if I were to take the square root of 0, how many solutions are there? 1. Square root of 0 is 0. There's no positive negative, right? Okay. Let's look at number 12 together on your
What's
notes.
it called, the discriminant?
I don't know. Okay, I motion to call it Sam. Nobody else? Okay. So, we're going to b squared minus 4ac, this junk. Not a sentence I planned on saying today, but I'm okay with it. B squared minus 4ac. Oh man, we're going to have to think a little bit. So what's 5 squared?
25.
Okay, now, let me give you some advice here. See how it's negative times negative times negative? We know it's going to be minus, right? And then I'm just going to multiply. So 4 times 3 is 12 times 8? 96, which gives me negative 71. The square root of negative 71 has how many solutions?
0.
Yeah, so no solutions to this one.
Wait, what was the formula again?
B squared minus 4ac. Yeah,
So you have to multiply 3 by negative 3 or negative 8 first.
it doesn't matter. I just know I have a negative times negative times negative, right? So there's an odd number of negatives. My answer's going to be negative, and then I just do 4 times 3 times 8, any order I want. You get the same. Because the commutative property of multiplication. Cool, so the discriminant's kind of nice because then we just know how many solutions there are. The next 2 classes we have, we're going to learn how to solve these. So we'll learn how to solve by 3 things. Algebra, like solving for a variable like I showed you. We'll learn by factoring. Do you remember when we were factoring trinomials, I said later in quadratics I can look at that and get an answer because I can, maybe you don't remember, but it's going to be nice. And then the quadratic formula, which is the most labor intensive. But sometimes it's the best, easiest way, even if it is labor intensive. So let's get after it. Finish this PDF up, guys.